All right, this is going to be a quick little video. Well, I say it's going to be quick. I'll probably rattle on and it won't be quick. So, but we'll see. I had a viewer comment on, I don't remember which video. Oh, the video about how much it costs to go roller from Flat Tappet, and he made a statement about flat tappets. Small flat tappets will actually make more power because they're moving the valve at a faster rate. So we're going to look into that and see if there's any truth to that statement. So stay tuned and we're going to get into it. All right. So, I mean, there's a lot of variables in this deal, but what we can do is let's just go over here to the cam doctor. Let me start this screen recorder. Okay, so I've got two lobes pulled up here. One of them is both are our lobes, and the hydraulic. One of them's a hydraulic flat tappet. One of them's a roller flat tappet. Neither one are like super aggressive or any super special lobe design. I mean, it's just kind of normal stuff. There are some definitely more aggressive stuff, but does that always equal um, more power? We're going to kind of look into that. So, anyway, these two lobes, let me turn off the flat tappet. So, this is a roller. It's 205 at 50. Um, it's nothing super special. It's 300 lobe lift. It is, let me pull up all the data. So it's 261 at 6, 234 basically at 20, and 204.28 at 50. And then 200 is 118. And it's 298.7 lobe lift. So the hydraulic flat tappet is 266 at 6, 233, basically 234 at 20, and 204, well, 204.71 at 50, and then 107 at 200. So the 20 and the 50 are pretty much identical, but the 6 and the 200 are different. And the 200 being smaller is, you'll see why that is, but a bigger 200 is generally a faster cam. So let's turn them both back on so you can see the velocity is higher on the roller. And pretty much it's always going to be this way because on a flat tappet, you are limited to how much velocity you can have because of the lifter diameter. So, like on a small block Chevrolet, pretty much just a little over 7 thousandths is the maximum velocity, um, just because of the tappet diameter. If you go to like a 904, um, you could increase that some, but it's still not crazy. I think even with a 904 lifter is still like 7.6 or so. So it's still not a lot. And a really lazy roller is going to be over 7. And something that's kind of spicy would be up toward 8.5. So we could make a roller in this design, 8.5 velocity. So it's always and velocity is how much it's moving per degree. So any day of the week, the hydraulic roller is moving faster than the hydraulic flat tappet. Down in the really low lift areas, uh, some designs in a flat tappet uh, are going to be a little faster, but overall, that's not equaling more power. And I actually found a dyno test of this very thing, and we'll look at that at the end. But I want you to see these examples. Um, so let's just pull up here. Let's pull up here to about 10 thousandths lift and just compare some numbers. And again, these are just run of the mill loads. These are not, you know, super extreme energy, blah, blah, blah. This is just normal stuff. And and I went back and looked through some load catalogs, and even the extreme energy stuff is still coming up shy at 200. So it might be less duration at 6, which is going to give you, a steeper angle. But regardless, you still got to keep the valve train under control. So whether it's a hydraulic or a flat tappet, you still just can't, you know, top fuel it. It just don't work that way. Um, so at 10, so that's 10. So we on the roller, we like two thousandths velocity, and then on the hydraulic, we are 175, and then the acceleration is 2.5, and it's about 2.5 on the roller. So let's zip up here to 20. There's 20. On the flat tappet, we are 3 velocity and 3.3 acceleration. On the roller, we are 307 on the velocity and 288. So, I mean, it's just, and then once you get on up here past 50 and on up, it's done. The roller is miles ahead. So 50, we are at 50 lift, we 5.3 on velocity, 5.2 on the flat tappet. The roller acceleration is 318, and flat tappet is 258. So, we already slowing down, way down. And then if we come up here, let's just run up here to 100. All right, at 100, the roller is 7298 on velocity, 6611 on velocity for the flat tappet. Acceleration 13163. So it's checked out. So another one, and this is a baby duration. So I was like, well, do I got anything that's a solid flat tappet and a solid roller comparison, just to see, does that make any difference? And I had about 6 flat tappet cams, just normal run of the mill hydraulic flat tappets. And I run 6 different hydraulic flat tappets, and they were all this outcome was the same on 6 different cams. Again, they're just normal everyday part numbers, nothing aggressive. So keep in mind that there are some stuff that down low may have more velocity and acceleration, but again, we're going to find out in a minute whether that actually equals anything at the dyno. So let me turn these two off. That's not what I wanted to do. So, all right, so this is, and this one. Okay, this is a roller of mine. It's 269 and 420 low lift. It's not super crazy aggressive. It's just a normal. It's just a normal solid roller load for that'll live. It's just not trying to kill parts. All right, this is a solid flat tappet. Same deal. It's not overly aggressive. It's got a lot of asymmetry on the closing side. Higher PM deal with a lot of rocker ratio, and my solid is also for a fair rocker ratio. So I felt like these two would be pretty comparable and they're really close on duration. They're not way far away on lift. I think the flat tappet's like 400 lobe and mine's 420. So it's similar, right? But again, pretty much always the roller's going to have more lift. That's the beautiful thing with the roller is it's not velocity limited, so you can just keep making it taller. I mean, there is pressure angle limits to tear, but generally you got to get pretty spicy to get into trouble there. So let me just overlay them, and you can see that. So the red lobe is the roller, and the black is the flat tappet. So down here in the low areas, they're almost identical. You can see um, some difference on the closing side just cause of the asymmetry of the roller, but the opening side, I mean, they're almost just identical. And if you notice the velocity trace, it's almost identical, other than the roller just continues to increase velocity, where the flat tappet has to stop because it can't it can't get there, or it's going to be too fast, and then it's going to be tearing stuff up, or running off the edge of the lifter. So I feel like, and let me see if I can just show you the, so it's verified here on the screen. So the roller lobe is 269. So it's 302 basically, rounded off. 302 at 20, 269 at 50, and 187 at 200. And it's a 420 low lift. The flat tappet is 298.88. So again, they're really close. I mean, the flat tappet is just a tick smaller at 20, but nothing crazy. And then 267.75 at 50. So we're talking about a degree and a quarter difference between the two at 50. And then the 200 is 178. Um, and then it's 392 low lift. So it's not far apart. I mean, 28 thousandths. So, I felt like those four lobes are really comparable, and they're normal stuff. Nothing, nothing. None of them are like exotic. So, having said that, and again, that velocity limitation is generally the deal. That's going to area under the curve, because the rollers being able to have more lift is always going to be, I mean, it's pretty much always going to be beneficial. I mean, all the extra, because it's getting bigger at 50, the roller just pulls away. So you've got all of that time, and the valves getting open more, and the curtain area is getting bigger, and the head can really flow. And so I just feel confident you're always going to see that roller make more power. Now, there may be some instances where a flat tappet wins, but I haven't seen it. But if you have an example, send it to me and I'll absolutely, we'll put it in a video and say, hey, I was mistaken. So that's that. And I think that illustrates what's happening for the most part. And this translates right over. I looked at the valve motion, and what you see at the lobe is exactly it's the same outcome at the valve. It's just bigger, but it's still the same outcome. So there's no the valve motion follows the lobe in this scenario, but it just multiplies. So, and I mean, it's been said that you can make a flat tappet make the same valve motion as a roller. I've heard that. Um, but because of the velocity limitation, I don't, I don't believe that is an emphatic statement always. You may have to do it with rocker ratio to get there. I don't think with the same rocker ratio that it's possible. Little bitty stuff, yes, but big stuff, I don't think that's gonna happen. I don't believe. So I got a. I'm gonna stop this screen recorder. I have got a dyno test that Hot Rod Magazine done, and I'm gonna hang on. I'm gonna put that stuff on the screen because I thought it was pretty interesting. All right, so here are the dyno results. So what they done, uh, Freiberger and uh, Steve done this test. So this was a 383 Mopar, aluminum heads, nice intake, headers, whole deal. And I'll link the article in the description. But so they started with a 214, 224 flat tappet cam, just a standard flat tappet cam. Then they got comp to make the most aggressive 904 specific lobe flat tappet that they could get. And they done that in a 231, 237. And then they had comp do a 214, 224 hydraulic roller, which matched the first cam. So this is the horsepower of the deal. And the so as you can see, so let's just pick 3,000. So at 3,000, the flat tappet, the small flat tappet was better than the big flat tappet, but neither one of them was better than the hydraulic roller of the smaller duration. Then let's pop up here to 4,000. Same scenario. The big flat tappet, except the big flat tappet overtook the small flat tappet, but neither one of them are better than the hydraulic roller. And then we go to 5,000. Again, same scenario. And then where's it quit? It's like 5,200. So again, same deal. The hydraulic roller is better everywhere, horsepower wise. So let's look at the torque. All right, so at 3,000, the hydraulic roller is still better. At 4,000, the hydraulic roller is still better. Where's it quit? 44. Let's see. Yeah, about 4,400, and the hydraulic roller is still better than everything else. So I just I just think you're going to see this trend every time. Again, there may be some instances and some special stuff, but I believe that if you got a hydraulic roller that's not making as much power as a flat tappet, it's just a really bad hydraulic roller. Because if it's designed properly, I think it's just going to be better everywhere, every time. And again, if you have examples of a flat tappet better than a hydraulic roller, and you actually have all the data, the load data, the dyno data, all of that stuff, then send it to me because I'd like to see what's going on because I just about guarantee you it'll just be a horrible design that's doing it or just a misapplication or something. But again, this is just, I've heard this statement multiple times about a hydraulic flat tappet will make more power than a roller. And I've just never seen it. It may be happening, but I've never seen it. And like I say, I went back and looked at several companies' load catalogs because I don't do flat tappets. I mean, we used to grind some, but that was early on, and I haven't done flat tappets in a really long time, so I don't have all the that data in my mind. So I just want to make sure I'm thorough. And again, I did see some loads in several load catalogs that the 6 is really short. Um, but again, does that equal more power every time? Because there's lots of other stuff going on in the curve more than just what's happening right off the seat. I will say that I believe that a really short 6 is gonna idle better, have more manifold vacuum, and be slightly easier to tune as far as getting the carburetor happy and that kind of stuff. If it's EFI, it don't really matter. But I just want to clarify my position uh, and try to be thorough with the explanation. But again, um, I just think we're going to see over and over again the roller is going to win. If it's a good design, the roller is going to win. And again, you don't have to, not only is it winning power wise, but I think you're going to see that just longevity and all of that kind of stuff is going to be better. And I know there's, 13 people out there that's never seen a flat tappet die. And they put them in all day long, and it's just everybody else is crazy. And I dig all that. But I know hundreds of people that just have trouble. So I just still think a roller is a safer option. It's going to make more power, and it's just easier to deal with. So I hope that was educational and entertaining, or both. Thank you for watching. Leave me a comment. Tell me what you think. And again, if you've got a scenario that's different than this, shoot me an email. I'd love to see it and just let's unpack it together. Thanks so much. Have a great day.